All right, hopefully we're going live. All right. Cool. All right, so we're gonna get a little started with playing with my ECU. It's a race car. It's kind of cramped. If I turn on the camera over here, give you a little tour. As best I can. You know, it's got a very compact cockpit. I'm sitting in the driver's seat. Instrument cluster, big tack, pretty well stripped out. You know, nitrous controls, not currently in use. It is a power glide, so it only 2-speed automatic, or sorry, 2-speed, not automatic, just only 2 speeds. And transbrake, which was my arch nemesis recently. It failed, so I wasn't able to do much more. So first thing I need to do is actually start the car up, and this is slightly complicated. So I've already turned power on at the back of the car at the power disconnect. And the reason for having a full power disconnect, it's if you get into an accident or you need to shut down on the track, it's a quick disconnect. So they can hit it externally, and basically it's push in to disconnect the power. We can take a look at that sometime, but I have a really short cable on this camera, so it's tricky. So now that I actually powered up, you probably hear the fans starting. I am actually wearing a headset and a noise-canceling headset with a boom mic because this thing is loud, and you'll get to experience that. So with it turned into accessory position, we get the computer turned on, also the oxygen sensor system turned on. Now the thing with oxygen sensors is if you actually start them up before the engine is running, you'll destroy them. So we'll go through that in a minute, but I'm going to switch over here to the desktop, and you can see I'm going through and switching into the actual, the computer is now turned on, and I'm going to go ahead and take the file I've got. Now one thing I've been playing with is the injection timing, because I was having difficulty with the overall idle performance and getting it to behave. So basic screenshot setup, you can see this top section is your readout of all the, I still have auto power off turned on the camera. Where is that? Cool. Where was I? Great. So what we've got is the top section of this display is the readout of live data from the actual ECU and its tuning parameters. And the bottom is actually right now the fuel table, but we have other options I can switch into, for example, the ignition timing table. And there's a lot of different other different tables that we can play with. EOI is the end of ignition timing, which is what I'm actually going to be playing with a lot today. And you'll notice that the lambda, which is the oxygen sensors, are currently reading at 0.74, even though the car's not running. And in free air, it should be 1. Now, the reason that's happening is actually that I haven't turned on the oxygen sensor controller. It's pretty stupid and actually requires about 6 button presses to get it turned on. But first things first, I'm going to get the car started. So I think I've got to the point where it'll just start up, and you'll see the map and, you know, revs and everything else start to go through. So let's see what we get. Oh, I still have cold compensation turned off, don't I? Cold start. Oh no, it's good. 51, 21, 20, 20, 20. All right. I don't know. What if I go back here? So the reason I've been playing with the injection timing is this has an extremely large cam in it. And what that introduces is a lot of overlap where the intake and exhaust valves are open at the same time. And so a lot of fuel can actually get sprayed directly through the intake valve out the exhaust valve as it's going through that section of the stroke. So the way that's measured when we're on EOI here is degrees before top dead center. And in a 4-stroke engine, that's before top dead center on the beginning of the compression stroke. So, or sorry, at the end of the compression stroke. So at the actual firing time. So if I want to go before that firing time, 180 degrees before that is the beginning of the compression stroke. And 360 degrees before that is the beginning of the intake stroke, where it's actually drawing into the intake. So this sets that the end of the injection will finish about halfway through the intake stroke. That's pretty normal. It was previously set to 400, which would actually mean it was spraying fuel into the intake while the intake was closed, or at least just barely opening. And that might make sense at the high revs, but at low revs, that doesn't make any sense at all. So let's see if we can get her to start now. There we go. Now I can also come in and view the actual live details here. So this is giving me more of the main view that I would see. What I actually probably want to see is the trim view. So because I'm starting cold, you can see ET comp, which is the engine temperature. It's actually adding a lot of fuel because the engine's still cold. And as it warms up, that'll keep decreasing. And I really want to get the engine warmed up because I haven't worked out the cold settings at all. I'm still working on a hot idle. So my best guess is that with the injection being timed better, oh, nope, it needs more fuel. Degrees before. So I actually want this to be closer to the beginning of the compression stroke. So I'm going to bring this down to about 210 and this to about 240. Try and get it away from that time where it's actually sitting open. Because now we're running, I got it's hunting, and what it does is at the low range it gets really rich, and then it's running so rich it zooms up in engine speed, but then it can't sustain it when it's up that high, so it falls back, and so you have what's called a rich, lean hunt. Which is really interesting because that means I finally have yeah, we're still running. Okay, what about 4.8, 4.7? Just checking to make sure the stream is up. All right, so still waiting for it to actually finish warming up. Last time I played with this, it was actually having a very rough time, and I think that was because of the injection timing was so ridiculously off. So now that that's a little bit closer, like I said, I changed the low end to about 210, and 210 degrees before the top dead center at the compression stroke, basically at the ignition time. 210 degrees is going to be really close to the end of the intake stroke, and that just means that it's actually going to get a lot of time to spray fuel in, where hopefully the intake is actually, or the exhaust valve is actually closed. Oops, wrong table. So it's still struggling. What I want to do is, I suggest not getting about more than about 30 degrees out when you do this, but I'm getting warm. There we go. We're starting to get a little bit of balance. This thing makes all sorts of noises. So one thing I can do now that she's starting to warm up is turn on the oxygen sensor, which, let me show you what this looks like. This is pretty freaking ridiculous. So I accidentally hit the wrong button, but it's, so you have to come in and say, I want to go into advanced. Yeah, I want to turn on the analog output. I do not want simple mode. I want the high resolution mode, and I want you to use both O2 sensors individually. I have to do that every time. Please do not buy this air fuel meter for your race cars. So with this, I can actually see when it's running lean and rich, and so that'll give me a good indication of how to adjust the fuel, as well as just listening to it. But this is really helpful, and it actually shows up in the user interface here too. So now you'll actually see the lambda, and it starts out at 0.65, and basically that's it saying it doesn't have a reading. It's when it runs off the map, and that makes sense at low RPMs. It doesn't actually know how to, or with that little exhaust, it doesn't actually know how much, it can't analyze the content as well. And that's pretty normal for a lot of sensors. There we go. You know, a little bit of hunt there, but not bad. Not bad at all. I do have the chat up if anybody has questions. See, even now it's still, the engine's so cold. 52 degrees C. Yeah. So now I'm actually trying to accelerate it a little bit, and what I did was I gave it a little bit of throttle, and what I'm finding is it didn't actually have enough fuel down here with that much air to kick it into going. So what you just saw was it asking about the quick lambda feature. So there's a table in here that lets me specify the lambda, which is essentially the same as your air-fuel ratio, normalized around the stoichiometric fuel ratio. So instead of being 14.7 for gasoline to 1, it's 1.0 or 1 to 1 for stoichiometric. So I had already preloaded the table, and that's why you see it in the UI here. It has LA table 0.95. At this operating point, I've already configured it for I want it to be 0.95. And then up at the top, you see the lambda of 0.93. That's the actual lambda being read from the oxygen sensors. So that combined gives you this diff, and when I hit Q, it actually calculates what I want it to be. It calculates the delta between the lambda and the table, looks at how the fuel table is adjusted, and basically adjusts the fuel table automatically to approach that particular lambda that I want. So the fuel table only works in 0.5% increments of what they call the injector pulse width, which is a couple of milliseconds. It's a configurable thing. I think I have it set to about 16 milliseconds. You have to be careful about your choices on how that works. But revving it up a little bit, now if I look at my trims, engine temp comp is 0, air temp comp, we're doing okay. So basically we're out of the cold start. If I let the engine rev down, this is where we should be. Now, what it seems to indicate is that right now we're maybe a little, yeah, we were a little lean there. So my expectation is it should be idling about 1,000 right now, but I don't actually know what the right idle RPM is. If you have an idle control system, you can actually pick your target RPM, and it will adjust the throttle cable or the throttle body to actually hit your target RPM. This car doesn't have that, so ultimately the throttle plate is in a fixed position, and now it's just going to be whatever it is that is the appropriate amount of fuel to match that that particular amount of air coming in for it to decide where it's going to sit. It may very well be that with this much air, it's supposed to sit around 800, and a little odd, but not unheard of. So if you're looking at the table here, you may be wondering these numbers on the left and at the top what they mean. Well, this is the engine speed in RPM if you haven't figured that out. And on the left, this is actually the manifold air pressure. That's because of the supercharged engine, looking at simply the throttle pedal angle can be tricky. So instead, we actually measure the pressure, absolute pressure of the air inside the intake manifold and use that as our indicator of basically how much air is getting pulled through the intake and try to adjust from there. So when I push on the gas pedal or the throttle pedal and it's idling at, say 700 or 800, you'll actually notice that the map will jump up to 100. What happens is I'm opening up the throttle plate and there becomes enough air that the manifold pressure, there's more than enough air there for how it's going to run. So it just needs to be adjusted to actually have the right amount of fuel to meet that. Right now it seems I'm off somehow, and I'm not entirely sure how, that it when I open it, it seems to jump all over the place. Now, I just lowered that because if I look at this diagram up here, what this is telling me is where the actual map and RPM track relative to the cursor position here. So here I'm in this square at 100 kPa and 870 RPM, and so it's telling me that in that space it's actually slightly below that, but if down here I look, it's also slightly above. So it actually balances between these two settings, and that's part of the whole mystery of this thing is, in this case it's closer to 4% of the injector pulse width, but part of that surge is actually, if it just hits up a little bit higher, it's getting a big increase in what it should be doing fuel-wise. And so you see that big jump in pulse width, injector pulse width, and then you get a surge. So now I have okay. So now that I'm under load and I'm giving it fuel, or I'm giving it air, what I'm finding is at those low RPMs, I actually need a lot more fuel. Yeah, that's really tricky with that big of a jump there. Let's see how it behaves if I... Now what I've noticed is that with the cam, there's sort of an inflection point. Once I get about 1,000 RPM, that's where it really takes off, and so it may very well be that I still need to play with the injection timing, that maybe that's actually still too late here. We could do that really quickly. So a lot of what it is right now is I see it, 4% is about right for it to idle properly at these. But with that huge jump from 4 to 10% right there, it's just going to keep doing this loping of. It's not actually harmful, but basically it's when it sits there at 4, it's slightly rich, and then that builds up just enough that it starts to surge, and causes a few problems. Well, one thing I got to do while it's running and the engine's warmed up is actually top off the transaxle fluid, because I recently had to drain it all when I put the new transbrake solenoid in. And when you fill a transmission with fluid, you run into this thing of, it seems like it has plenty of fluid, but then you actually have to measure it hot and running in order to have any idea. So that's part of what's going on. I wonder if I can actually get the camera out here. How much cable do I really have? Oh, this is a lot longer than I thought it was. Oop. Well, there went my camera. So, transmission fill in this car is there. I already checked the fluid, and it's basically empty. Well, not empty, but not nearly enough. It's not even on the dipstick, so give it some high-quality Lucas Sure Sift. Now, to be clear, I already put 3 quarts in, and it was reading full when I did that. I don't actually, I knew it was going to do this, so it wasn't completely empty. I wouldn't do that to any mechanical component in a car. Lovely view of my garage. Okay, let's see what we can get here. Gonna try to do this one-handed. There we go. So, it's a dipstick. Is there fluid? A little bit, but not enough. Now, another thing to keep in mind when playing with the transmission is you have to check it hot and in park or neutral. But it's also going to change how the load on the engine behaves. In park, it shouldn't be doing much, but you know, it is spinning fluid. So you get a little bit of difference. It'll be much more when we actually start looking at no, we're at least on the stick now. So that's about 4.5 quarts. And I'm going to do another one here. This is really tricky to do. Let me just switch you back to the computer view. In the meantime, oops. There we go. Still a little low. Alright. Well, hopefully this is enough fluid and we can call it done for a while on the transmission. Just one of those tasks that had to get done. That seems okay. We'll check it again next time. It's in the range. If you're wondering, do my neighbors care? Yep. They've complained a few times. They're pretty gracious about it, actually. They're mainly concerned that they have to sleep. So I try to be kind and not run too late, especially if it gets after dark. But so what I'm going to do is now put it into drive. Actually, I'm going to test one thing. I'm going to put it into reverse and hit the transbrake. So when you have a transbrake, I guess this deserves a little discussion. The concept of a transbrake is that you have a solenoid that allows the reverse gear to be engaged independent of the normal shifting gear. So when I put the transmission into drive, I can still engage reverse by pushing down a separate button that triggers the solenoid. Now, why in the world would you want to do such a thing? Well, when you're actually trying to take off at the starting line, you want your supercharger to be built up and have plenty of boost so that you get a really good off-the-line performance. Now, to do that, you want to preload the engine, but you can't actually go anywhere. So you have your transbrake, which lets you engage both drive and reverse, so you can rev up the engine. The car's not going to go anywhere, and it's basically just going to make the transmission fight itself. You should only do this for short intervals. And so, yeah, the transbrake solenoid died before, and that's why I had to drain the transmission fluid and everything else. So I actually want to test that it actually works. So here we go. We may actually just stall the engine when we do this. No, actually a nice clean engage. Cool. Now I can put it into drive, and now I can figure out a little bit more what's going on, because it needs a lot more, it puts a lot more load on the engine now, so we can there we go. See, it's all happy now. Listen to her. And if I take it into neutral, she's going to rev up and then back down and hunt around a bunch. That's okay. I'm all right with that. May very well be that it's actually the 6.5 that's causing part of that. Yep, it was. Smooth. You know, I can't really see the Twitter responses, but let me look it up on my phone. Yeah, if you jump into the YouTube chat, it's easier for me to answer while I'm on instead of Twitter. But To answer your question, Jesse, there are a few details on my blog, kc8apf.net, about the car and kind of what its basic overview. I haven't done too much detail. My co-owner is really wants to be a little bit secretive about it and not reveal too much for when we actually get up to the track and have some competitions. So, yeah, it's a thing. Oh, listen to that. But I guess I can go over a little bit of the basics while I'm playing around. The base car was a '96 Mustang Cobra SVT, whatever. They had all the different labels on it. Which is a 4.6 liter V8, and it's actually been considerably rebuilt since then. So it's had a supercharger added. It has a nitrous system, lots of different overhauls. The rear end is completely rebuilt for drag purposes. Suspension changes, wheel setup, and I spent a lot of time actually building out the electronics in the trunk because a lot of the electronics has been complete and utter trash. Not to disparage the previous owners too much, but they really didn't know what they were doing. Mechanically, they were really good. Elsewhere, not so much. Well, based upon that, you know, it actually seems pretty darn solid. And I don't want to waste too much time. Yeah, no, it's unhappy now. And it's starting to get dark, so I'm going to have to shut down. Yeah, that hunting is actually interesting. So I suspect that when I actually go unload, it's jumping down into those 3 range down there, and I suspect that may just be a little rich when the MAF is actually a little. That's pretty good, yeah. It was just a little rich at the low ranges there. So I could go drive, but it's getting dark, and technically I'm not supposed to drive this on the road. So, yeah, I think that's it for tonight. So thanks for spending some time with me, and yeah, just going to close out here. All right. I successfully used Open Broadcast Studio.